Zoom.
Good?
Yeah, it's recording on your end?
Yep.
Perfect. Okay. That's one of the things I need to check. Right. So let's first start by going over your rocket. So we'll start at the front, so the nose cone, and then work our way backwards.
All right.
Don't mind me. Continue as.
All right, so we have the EW Aerospace Club. Starting at the nose cone, we have a G10 fiberglass nose cone with the bulkhead internally to hold the parachute the shock cord. Next is our upper drogue bay, which is our drogue over there. Has our drogue shock cord in the top of the avionics bay.
As well as payload.
As well as payload, yeah. So our E-bay is G10 fire retardant fiberglass 1/4 inch with 2 aluminum ejection bays on each side. One with 4.5 grams of black powder, one with 7 grams of black powder.
6 and 9.
6 and 9.
Yeah, because we increase it due to the lower pressure at higher altitudes.
And then we have external switches going through the body tube and avionics with this hole pin switch. And then 3D printed E-bay sled that'll house all of the our computers. Moving down to the back end, we have carbon fiber laid up, pre-preg carbon fiber fins, and then a hand wet layup fiberglass tail cone. The back end holding our motor tube is 5 wood center rings, all held in with Kevlar and epoxy. And for motor retention, there's a G10 fire retardant fiberglass bulkhead in there with another shock cord connector. And then the motor is held in with a bolt and the lock washer held in with the threaded rod. And at the top end will be held in with a lock washer and threaded rod internally in the rocket. And then for payload, Africa.
Yeah, so the payload, basic idea is it's a guided parachute. So we bought, it was from Apogee, it's sitting somewhere. We bought this little parachute from Apogee. It's a big mess right now. It ended up being very, it couldn't carry the weight, the 2 kilogram target, this thing's gonna drop like a rock. So we decided to, to upscale it it's 1.5x.
Each dimension is 1.5x, yes.
Yeah. So we tested this a bit. It does glide like we expect it to. The way it works is there's a lot of springs out here. They're grouped into anchor lines and control lines. So essentially, the anchor lines support the weight, and the control lines, they pull the back flaps, so it basically brakes on the side that's being pulled and causes the parachute to turn. So to use this.
That's typically how guided parachutes like that are steered by people who are people parachuting under them.
Right.
So on one side and it turns in that direction.
Yeah. We're basically just doing that with the servo here. So this was our first iteration of the whole payload, and we were doing some testing, it got damaged. But the idea is this guy lives inside of it with a servo that's able to pull the strings for the control lines. And it goes inside this casing. We redesigned this, so now it's going to fit inside our mascot swoop. And that's about it. It's GPS guided. Right now we're looking at our heading based on GPS coordinates. So as we move, we can see which way we're moving and where we want to be, and then realign that.
So does it target a specific GPS coordinate?
Yes. So it's going to be
autonomous. Where is that location?
At the moment, we have not picked an exact location for landing. It's right now, I guess we, for the first launch, we're going to determine a location that's safe outside the airspace.
Mm-hmm.
But we just got to confirm with the Rocket Association where we can actually touch this thing down. But the idea would be that we could assign the GPS coordinate to anywhere we wanted and potentially a flight path to get there. And that's kind of it. So deploy, fly along the path, and land somewhere safely where we can recover it.
What's the descent rate under parachute for the payload?
I don't know if we've tested it yet. I assume you mean without the brakes on, for full stop. It's going to have 2 stages where we're going to have a what's it called? Tie release. Cable cutter. That's what it is. It's going to have a cable cutter for initial descent, so it will kind of act as its own drogue. We won't have it completely bottled up, but enough so that it's not gonna drift off.
Since the payload is deployed at apogee.
Yeah, yeah. So it's got cable cutter for dual deploy, and then it should be able to go slow enough once it actually cable gets cut. Although we don't know exactly the speed.
And it's not steered at all while it's.
From 10,000.
No, not from 10,000 to 1,500. Was it?
10,000 to 1,500 was. It's just falling, and then the cable cutter, and then GPS guide.
So it'll go wherever the wind pushes it.
Yep.
Yeah.
And then we'll try to see if we can move it back once we're actually below the target altitude.
Okay.
And with
So for safety reasons, I'd probably recommend selecting a GPS coordinate that is downwind from the launch site.
Mm-hmm. Yeah.
So that way it's not going over the launch site under parachute.
Okay. Yeah. Good idea.
Just in case you aren't the last rocket in the silo.
Yeah.
Okay.
All right.
Although, that being said, we have had rockets come down under parachute pretty close to the launch site while we're launching rockets.
Mm-hmm.
But usually that means that we hold until the rocket lands.
Yes.
Yeah, that had been something we considered, that we could take it outside of the launch area so we're not hovering above somebody's launch delaying stuff.
But what's the descent rate after the parachute fully unfurls?
I don't think we've fully calculated. It should be roughly a little bit slower. I think 90% of the descent rate of the off-the-shelf one. I don't remember what the
Okay.
off-the-shelf one was.
It just has to be, let's say, I think it's less than 11 meters per second is the regulation for the rocket under main parachute.
Yeah.
So the payload would be similar.
Yep.
We're doing a launch soon, so we can be sure to report all that.
Yeah, there will be a launch this Saturday for testing the payload as well as the airframe.
I was wondering, that was moved from the 13th.
Yeah, we've had some small issues and have just decided to keep pushing it back and rather than risking our rocket. So Saturday is a go. We still haven't fully determined the motor yet because Tammy, our advisor, she has to leave early. So we lost one of our big launch dates, and we also haven't received our full-scale motor. So we don't know if we'll get a second flight in, but there will definitely be a flight this Saturday or Sunday.
We have 3 different motors to choose from. It's not an issue of not having a motor. It's an issue of which motor do we use.
Which one to use?
Yeah.
Oh, that's a good issue to have rather than not having one. What tracker is your payload using?
The payload?
It has an egg finder, I believe.
Yeah. Egg Finder Mini, I think. Yeah.
Okay, so it's a COTS tracker.
Yep. It also has a experimental one, but it will be relying upon the Egg Finder.
Yeah, the egg finder reports to ground. We'll probably pull data from the egg finder, as well as potentially another one. So with backups.
It's worth noting the experimental GPS is not going to be transmitting, it's only using
Yes.
that data internally.
Yeah.
What battery is the are the trackers using?
I think a 9-volt.
Using the tracker. We're going to be
Yeah, basically what batteries are in your payload?
7.6 volt life hose So they're the iron-based ones that are much more stable than lipos.
Yeah, lithium iron phosphate. Although I think for the initial test, we're going to use 9 volts, just because the LiFePos are hard to source.
Yeah, you don't typically run into iron, like small iron-based battery chemistry.
Yeah, they're almost exclusively made in China, which is an issue right now.
Yes. Yeah, one of my hobbies is electronics. So seeing the upsurge and it's like, oh, we're doing it. It's like,
It's pretty painful.
Yeah.
oh, forestall rebuilding my computer again. Sorry, I'm pulling up the battery thing. Double check that.
Yeah, I believe LiFePos are one of the ones that doesn't even need to be in a metal container because of their stability. It could be in plastic or metal.
What battery chemistry did you say it was again?
Lithium iron phosphate, so LiFePO. There might be a 4 in there actually, now that I'm thinking about it.
Oh, LiFePO4, yeah. 6.18.2.1. Allowed in any form factor and in any casing, yeah. So those are good. I've just never reviewed a team that was using this type of battery.
What do most teams use?
Probably Duracell.
Just Duracell 9 volts? Is that what most teams use?
All right, and what's the mass of your payload?
We're shooting for 2 kilograms. I guess we can add dummy weight to it and launch.
Wait, what did you say it was? I missed the first part.
Right now we're at 0.7 kilograms. We're trying to get it up to 2 and probably just add some dummy lead into it. Because I thought we had to get to that.
We also are going to be putting in a cooling fluid to the computer cold in the Texas sun, so that's going to add a bit of weight as well.
It was in.
Definitely will need more to meet the minimum.
Yeah, we plan on putting dummy weights into it as well as a cooling fluid for the computers. The mic's not great at catching up, but that's what we were trying to say.
And we probably expect a bit of weight to facilitate the ejection of the payload as well.
Mm. Yeah. Wait. With that, I'm pretty sure you're pleased that the minimum weight is 2 kilograms and not 4.
Yeah.
Like it was previously.
Yes.
Yeah, we got tired of having mostly dummy payloads, like mostly metal,
Yeah.
for like every payload. Yeah, just make sure to follow the DTAG in terms of what like types of metals and such you can use for valves.
Okay.
So just keep that in mind. And let's see, the payload you said was in the forward compartment with
Yes.
the drogue chute?
Yes.
Yes.
Okay, so that would push your center of gravity forward, so that's fine.
Yep.
All right, and the last part I have for the payload is just make sure that your team name, number, and frequency are on it, particularly because it's deployed.
Okay. Would that be radio frequency, the last one?
Yes.
Okay.
Yeah, so if it's transmitting, have the frequency printed on the payload.
All right.
Yeah, I can't think of anything else on the payload part of it. see, where were we in terms of running through the rocket?
Do we want to talk about avionics?
Sure.
Eli, do you want to take that one?
Avionics.
All right.
Okay, so here's our electronics bay.
See if I can do
We have some G10 rings in here, so these actually sit recessed in the bay a little bit. And then we have a modular system here so that we can mount batteries and electronics on this. It's a pretty typical avionics bay setup with a U-bolt and 3 threaded rods that run through. We've got 2 pull pin switches in line with each other there, so there are 2 independent switches, but they're toggled by 1 pin. And then we've got a aluminum main and drogue deployment charge wells with the connectors going through there. From there, we've got 4 quarter-inch vent holes to equalize the pressure, and then some places here for screws to hold it into the forward section of the rocket.
If I remember correctly, you were using 4 shear pins for the main?
4?
And I think it was 2 for the drogue, or was it?
It was.
Do I have it backwards?
No, you're correct.
Okay.
And those are nylon 440 shear pins.
Oh, 440, okay.
And then as far as the actual electronics, we'll be using a MissileWorks RRC3 as the backup, and the Perfect Flight Stratologger for the main. Or primary, rather.
Main. And you said the RRC3
Yep.
for the secondary?
It's specifically the RRC 3 Plus. It's like the
3
newer
Plus?
smaller. It's the smaller form factor version of it.
You mean the 2 plus?
No, 3 Plus. They have a new one.
3 plus? Oh.
Yeah.
I am a bit behind. I didn't realize they'd released a new version.
Yeah, it's basically the same as the old one. It's just smaller.
I mean, I would hope so, because the original RRC3 is like
Yeah.
this big.
Way too big.
The Plus is still a little big for an altimeter, but it's going in the right
I'll
direction.
hold this, I can grab it.
Uh-huh.
Yeah.
Okay, so you're using black powder for deployment.
Do you want to say the heights? What the heights those are at?
Yeah, this is what the new RRC 3 looks like.
Oh, wow. So it's like, this looks a bit longer than the 2 plus.
Yeah, probably a little longer, but it's about the same width as the old RRC 3, and it's like
Uh-huh.
half the length. So,
It was a lot cleaner, too.
yeah, and all the terminals are here on the bottom.
Uh-huh.
Works
Much
the same.
cleaner. And only 2 mounting holes rather than, I think it's 4 for the
Yeah.
2 plus.
Yep.
Huh. I'll have to look it up. And figure out what to do with my old RRC3. Probably use it for testing. Okay. Hardware. All right, let's take a look at the harness. Like the recovery harness.
Oh.
Is well.
Also, Zoom meeting, we don't have Zoom Premium, so it might end shortly, and I can send you a new link. as well.
Yeah, no worries about that.
All right.
I'm well familiar with Zoom's
Yeah.
restrictions.
So these are our harnesses. We're using quick links to attach them, along with the bowline knot there. The part of the cord closest to the attachment point is Kevlar, and then we switch to nylon for the remainder of it. And I don't remember the exact lengths, but I believe each one is about 30 feet total, somewhere in that ballpark. And then we have the same thing going on for the main as well.
And you said that was nylon?
Up here is nylon webbing, and down here is Kevlar.
Ah, okay. That'd be closer to the deployment charges.
Yep.
silver, and nylon. Okay, so that's good. Okay, so that looks like 9/16 nylon.
I believe so, but I don't know off the top of my head. At least.
It looks about the
Could
size
be.
for 9/16.
Yeah. Yeah, it looks about right. 'Cause- yeah. I have a
Okay.
pair of calipers.
What else are you using to protect the shock cords?
We have two, well, we have one for each, but they're 24 by 24 Nomex sheets.
Mhm.
Yeah, 9/16.
Yep, no more blankets.
We have them.
No more ones
I see one. That's not the same one we're using, but it's the same basic thing.
Okay. Are you just going to use the deployment blankets, or is there anything else?
I believe right now our plan is to just use those.
Okay. Let's see. What are you using for your main parachute?
Main parachute is 10-foot diameter, 50% hemisphere, ripstop nylon parachute. So CD is about 1 drag coefficient, but it ended up dropping us at was significantly under the 30. I think the requirements to be under 20 or 30 feet per second. If I'm not mistaken, we're at about 10.
Yeah, and that's feet, so like 3 and change meters per second.
Yeah. Currently, we only have 4 shroud lines on the parachute. We're going to have about double that by the time of the competition. We did make this
Okay.
parachute ourselves. So the shroud lines go all the way up the entire parachute rather than just having 4 measly connection points. We took the design based off of a purchased commercial off-the-shelf X parachute that had the nylon webbing shroud lines going all the way up the parachute. So for our test launch, we're going to launch with the 4, and we have to do a little reinforcement on the upper seams, but yeah, all the seams are sergered. It's the same design and manufacturing process that is used for the commercial off-the-shelf. Just we had the means at the university.
Was that from Rocket Man? The commercial one that you based this off of?
No, it was from a place called, I think, Sky Angel? Yeah.
We based
Sky Angel.
the shroud line attachment off the commercial off the shelf. We used the
Okay.
template. I'd have to look at to find the website, but we used the template we found online to get the form of the hemisphere.
Mhm.
Yeah, so the template's from online and kind of the design of the shrouds is from Sky Angel.
I was wondering, because some of Rocket Man's parachutes have the shrouds run into the parachute.
So yeah, and then that's the same case with the drogue. Drogue chute is 50% hemisphere, 36-inch diameter, and we have 3 shroud lines. But in this case, we just kept it to the pretty standard. We have about 4 inches there of contact with the shroud line on the chute, reinforced stitched, and then the rest is sergered all together. And then we use the calculators online to find our vent hole diameter and all of that. So, yeah.
What's the descent rate under the drogue?
That's in our open rocket. Let's get the right number.
We're currently pulling it up right now.
Okay.
Is there a timer on the Zoom for when it'll cancel?
It says it's going to kick us in about 1 minute, so we'll have to.
Do you want to
Okay.
restart it right now while he finds the number?
Yes, do that.
Would you, is that all right if we restart real quick?
That's perfectly fine.
All right.
Oh, there it is.
Nice.
Didn't even wait for it.
All right, halftime.
Okay, guys, what
When
do we
start stabbing your head with a towel.
It's still
Get your
recording,
race.
but it's okay.
Okay, everyone redesign the room while we're getting ready.
It's like we swap out the entire rocket.
Get the black one back there.
Grab that one out there. Like, oh, we finished. Well, you're gonna wait it.
It's in progress update.
It is some painting. Try pretty fast. Proprietary paint technology.
Let's see if in progress still here. It's different. I wouldn't be surprised if that's one.
What's the worst?
26.16 or something like that. More rock on this one? Yeah.
And then our main.
That's in meters per second. Yes, meters per second.
Do you not have anything else?
The main will not be accurate.
We can get it.
Because it's a hemisphere now.
I remember we drew it. Does that slow down or speed it up?
On good, guys.
All right, I just emailed it to him.
That's not right. 366. I bet that's supposed to be a 3.66.
No doka still. Pantopo.
5.3 in this one. I've got no idea where that number came from. That's in the progress update to fix document. It might be, but I don't know if the open rocket was set to the right parachute. And some of the changes that have happened over like the last month have not been saved properly. Did we submit it like that? I bet there's a point here.
Keegan, you might need to resend it to him. I don't know if I assume he got mine, but we'll see. I don't know if he just sees your message.
Colin's emails go to junk.
He needs to go to priority. Oh, never mind.
All right.
All right, we're good?
Yeah, 3.66.
Okay. Can you hear me?
Yep. Are you still
Yep,
recording?
perfect.
You're still recording, I assume?
Yeah, I didn't stop my recording.
Okay, we didn't either.
Although my audio might not be working for that first section. So,
We shall see.
but if you're recording, that should be fine.
All right. Sounds good.
Mine is a backup anyway.
All right. So, did you get the...
Yeah, the main descent rate is 3.67 meters per second. And the drogue is, I think, 20 something.
26.
26. Okay, that's what I said then.
26.
Yep, for the drogue and 3.67 with the main.
Okay, yeah, those are definitely under the required values, although I think I'll have to tell them to put for some strange reason, they're in feet, when we now require them in meters, but anyway.
Yeah.
And the colors should be visible.
Yep, red, white, black.
Uh-huh. Yeah, you don't find those colors in nature normally.
Yeah.
Okay. And you don't have any issues with tangling with your shot cords, correct?
No.
No.
We're doing a
Yeah,
test launch on
to be
Saturday.
determined. We'll see on Saturday.
True.
We were talking
like
about
it does, like you've deployed them like ground testing, they came out.
Yeah.
At least. So yeah, it's up to the airflow to determine it. And yeah, usually if you follow a good packing method, they shouldn't tangle.
Yep.
Okay, so altimeter selection is good. Are you using similar batteries as with your payload for your avionics?
Yes.
For our first test, we're going to be using 9 volts. But yeah, the plan is to go for the life pose. But I think both would work.
Yeah. And let's see. What's your wiring method like for your electronics bay?
So the wiring is something we're working on this week, but what we have is, when these are mounted in here, we're going to be using JST connectors here, and they're going to be keyed so that we can't plug them in wrong. And then we'll be soldering some connectors onto the end of these so that we can just plug it in that way.
Since those are the wires leading to the charges?
Yep, so these are to the
Thick
chargers
wires.
and then for the main side.
I would highly recommend labeling them.
Yeah.
Yeah.
Yes. Yeah, labels are your friends. Plus, I can guarantee that the safety reviewers at the competition, since I am one of them, will be asking about that.
Okay.
It's good to know.
Yeah, we'd like to see labels.
Yes.
Yeah, we'll be sure to label them, and we're also going to key them so that you can't accidentally plug a battery directly into an injection charge or something like that, because that would be bad.
We're also working on making a full checklist that we'll be going over to. So.
And we will be looking at that in the safety reviews at the competition as well.
Sounds good. Excellent. You want to talk about the pull-in switch too?
Yeah, so both the boards that we're using just have a switch connector, which makes that pretty easy. So we're just going to run some wires to this pull pin switch, which is kind of in the middle there, but there's a hole through there that goes to the outside. And so it completes the circuit when the pin's out and turns the electronics off once we put it back in.
As well, in the avionics, we have an experimental flight computer or ground computer made by Jaden.
Yeah, that's true. So we do have one more board here that's not commercial. It's not going to be controlling any charges or anything. It's just going to be recording data and transmitting it back to us.
Data logger connected to a battery. Okay.
Yep.
Sounds good. And does that have a switch?
Currently, no, but.
So how are you turning it on and off?
I thought it was going to be connected to the main.
Yeah. Okay. We'll have to add a third switch in line with the.
Well, I mean, I'm not particularly concerned with it. Like for example, being turned on before you're at the flight line. It's more a case of like battery life.
Yeah. Yeah. What we'll do is we're gonna print a third pull pin, so the pull pin switch can have 3 pressure switches in a row. We'll throw a third one on there and put it on a separate circuit from the rest of the flight computers to keep our redundancy as redundant as possible.
Yeah, it's mostly because let's see. You said this is your first competition?
Yes.
Yep.
In a decade.
Yeah, rockets could conceivably be on the pad waiting to launch for upwards of 30 minutes to an hour.
Okay.
Depending on how everything works. If we're really quick, it can be quicker, like faster. But if you're at the end of a salvo of, we do 20 rocket salvos. If you're at the end, then it could be close to an hour, if not longer, past the point which you left the pad or turned it on.
Wow. That's good to know.
To be honest, that's actually less time than I was expecting because some of the club launches I've gone to in general have been that high. So I think with the batteries we're using, those lithium iron phosphates.
And particularly, it's not transmitting, so that helps.
Yeah, so I think we should be okay there, but it would probably be a good idea to put in an extra switch.
Yeah, at very least, that would mean that it's only running at past the point where you turn the electronics on. And that's usually pretty close to between turning the electronics on and everyone leaving the pads, we usually try and get it below 30 to 40 minutes, if not shorter. Because at that point you have like 80 black powder charges and the motors. So, yeah. It just decreases the amount of time the electronics have to run. That is the avionics. Recovery. Payload. All right, let's take a look at the lower airframes, like where the fins are. Okay, so fins, carbon fiber. And that's solid carbon fiber, so that should be fine.
1/4 inch thick, 26 ply.
Yeah. How are they secured?
So they are all the way down to the motor mount with interlocking with the centering rings. So it's all Kevlar epoxy in there, as well as the fillets are Bondoed, but underneath that it was Kevlar epoxy, and we wanted that smoothness. So that's what Bondo's for.
Are there any? That's not what I wanted. Are there any interior fillets?
Yes.
Yes.
Okay, good.
All the interior fillets, we also mixed chopped Kevlar with the epoxy to make it.
I've been noticing that with a couple teams. Okay, good. Let's see. Doesn't look like you're using tip to tip.
No, the body tubes are Wildman ones. They're Wildman body tubes, but the tail cone we did lay up with, I think, 7 layers all the way around.
Yeah, it'd be hard to find a commercial tail cone of those dimensions.
Yeah, we made it off of the old club's nose cone. Yeah, the mandrel for that.
Alright, so the fin attachment looks good. But you're not going extremely fast.
Yep.
So if I remember correctly, you have a pretty good calculated fin flutter.
Yeah, I think we have, what, 2,600 feet? 2,600 feet per second.
Which I think is more than twice your maximum velocity.
Yeah, 3 times.
Yeah, almost
2.5, yeah.
Yeah, I'm pretty sure you have one of the highest fin flutter calculated velocities in at least that I've reviewed.
Yeah.
Redundancy.
So you're definitely safe there.
Yeah.
These fins will not flutter.
No.
Well, I think the fin flutter, like that's the maximum the fins can flutter before they start failing.
Yeah.
So they'll probably wobble a bit, but definitely not past the point where they wreck themselves. All right, what's your motor mount made out of?
So the motor mount is the G10 fiberglass used in the avionics bay. Kevlar epoxied 40 inches up. The motor has the screw-on thread that goes the whole length of it and gets lock nut and lock washer and nut threaded onto the 3/8 threaded rod.
And that looks like a 1/4 inch, or is that 1/2 inch?
3/8 inch rod.
3/8, okay. Motor tube composition fiberglass. And the motor retention, that would count as SRAD, but it's a 3/8 bolt, basically.
Yeah. Lock
So
washers
that,
lock washers and maybe some Loctite so that it doesn't come out.
yes, definitely recommended with that. Let's see. Is there anything at the lower end that the motor, basically what is the motor pushing against?
Just the motor tube and the tail cone.
Ah, so it pushes onto the tail cone.
Yeah.
Yeah, it pushes onto both of those. So
Actually distributes
Yeah,
the
you
force
gotta
already.
unscrew that. No, it's not long enough. It's all right.
You can put it, it'll fit.
It's fine, it's fine.
Oh, this isn't the right.
This isn't the right
Yeah,
threaded rod, yeah.
Okay, so yeah, it doesn't, oh, very nice.
Yeah.
I had a team last year that wanted to blow the exhaust through about 6 inches of their tail cone.
That would have been interesting.
Or at least they wanted to. They asked me, is this fine in terms of heat transfer? And no. But they ultimately got rid of their tail cone completely. So
Yeah.
that was good. Okay. Yep. So the motor won't fly through the airframe. What are your centering rings made out of?
We have 5 centering rings made out of 1/4-inch birch plywood. So there's 2 in the tail cone, 2 in the coupler that connects to the tail cone, and 1 at the very top of the motor mount.
Is this one the wood, or is that
Yeah,
one?
that one's the wood. So yeah, 5 wood, and that one's also for centering.
Yeah, and then we've got some I think it's actually G12 fiberglass in here for the bulkhead that actually takes the force from the rod, and then also for the avionics bulkheads.
Moving through here. Where are your centering rings located, or will be located?
So there's 2 in the tail cone, split I think 6 inches apart.
You can kind of see them.
There's
the rail buttons,
Oh.
not the centering rings.
We have them out right now because we're like painting. So there's one at the top of the tail cone and 1 all the way up here.
Okay. So they're both in the lower airframe.
Yes, we might move that one back. We were talking about that to increase that off the rail velocity because right now we're at.
You might be able to lower it a bit.
Yeah.
Just don't lower it more than a couple inches, like up to 6 inches.
Okay.
Because if it's too short, you'll run into other problems.
Yeah.
And shortening it to
Increase the to increase the off the rail velocity.
Dynamic stability off the
Yeah.
rail. So by making it so that
you're increasing your effective rail length.
Yeah.
Yeah, that makes sense. Speaking of effective rail length, it's the point at which the upper button leaves. So you take the total rail length and you subtract the distance between the 2 rail buttons. Okay, so you're not using fly away rail guides. And these are commercial rail buttons?
Yes.
Yep.
Okay, and so they'd be of a good material. And 15/15 based on the screw size.
Yep.
Bullet count is fiberglass.
There's one of them right there.
Yeah, that's definitely 15/15. And speaking of that's black powder. Size of their fine couplers, motor. They're using, no, that's not what so many sections. What is your current off the rail velocity?
At 20 mile an hour. Velocity. 74.4 feet per second.
Okay. And that's with no wind, or?
That might
This
be
is probably the 20 mile per hour scenario.
15 mile an hour winds.
15, okay. So that's... It's kind of difficult to say how often that would occur, considering that this is a new launch site. None of us have been, well, I haven't been to it, and I haven't looked up the weather, but it's about the same, latitude as Las Cruces-ish. And it is, a flat plain, it is Texas. So if there are winds, they won't get interrupted by much.
Yeah.
But of course, we'd prefer to launch rockets with less wind than more. But if it's 75 at 15 mile per hour winds?
Yes.
Yeah, launching at lower winds will definitely be safer.
Yep.
Okay. Yeah, so if you want to increase it slightly by moving the rail button, that's perfectly doable. Just don't move it by much. And as myself and a couple other reviewers have pointed out to me, 75 is still 25. Like, you're still well above the minimum required, which is 50 feet per second.
Yeah.
So as long as your rocket is decently stable, you have good size fins, so you should be fine in. And if you want to increase it slightly, go ahead.
Yeah.
Just be careful and don't move the rail button too much, as I said before. So 75 should be fine-ish. All right. Let's see, so propulsion-wise, what motor are you planning on using for the competition?
M685.
Okay, so that's the same as before. And that is a COTS motor.
Yep.
And are you using the igniter that does come or will come with the motor?
Yes.
Okay. That is already done. Do you have the motor?
No, we've called them a few times and they have not.
So we ordered the motor well in advance, probably a couple months before the IREC deadline. I think we ordered it beginning of January. So
okay.
Our motor is currently in the works of being made. They did make mention that if the motor is not done before the end of May, which we were trying to throw another test launch in, they will ship it directly to the competition.
So no matter what, you will have a motor in hand in Texas.
Correct.
Yeah, and even if they don't pull through, we have a M18
1780.
1780. Well, we also have the 18.
No, we have the 18,
and that one would get us above 10,000.
Okay.
It turned
Yeah,
out
it's a higher thrust.
Yeah.
Yeah, I think it's 9,000, but it's still pretty. It's up.
And I think does it have more impulse than the 680?
It does, yes. Yep.
Okay, yeah.
No problem anymore.
Mm-hmm.
We just didn't know that the old advisor for our club had brought it home after he retired. So after a conversation with him, he's like, "Oh yeah, you guys have some more high power motors." It's like, "Where?" "Well, at my house."
Yeah, it's like I have those.
Yeah.
Okay, good to know that you have options. That's always nice. Okay, the body tube is fiberglass. Looks like a Wildman.
Yep.
Yep.
They make good fiberglass. I did my L3 on a Wildman kit.
Nice.
And I'm not seeing any significant holes in the body tubes. Lengths look good, so that's fine. Let's see. So you don't have any bulkheads attached by screws, do you?
No. Everything's Kevlar epoxy.
All right, yeah, that's good. All right, the only other thing I have on the body tube is that you will need to have your team name and number on the frequencies on the rocket.
Okay. Yeah, we forgot that not really forgot. We planned it and we didn't realize we were starting painting soon. So the whole top half's being painted and we're clear coating the fins, but
It'll look much nicer by the time
yeah.
it gets down there.
Yeah. Like I didn't actually paint my L3, but mostly I think that's because the person who recommended that I don't paint it said that's like, Eric, you're not very good at painting rockets, so don't paint it. Still not particularly good. Still practicing on that. All right, yeah. So you will need a team name and number on that. Okay, the nose cone is also fiberglass?
Yes, from Wildman as well.
Yeah.
Aluminum tip.
Aluminum tip as well.
Yep. Aluminum tip, so that's all fine. What's the shoulder lengths on the nose cone?
The 6 inches.
Okay, yeah, so 1 caliber.
Yep.
And is it the same for all the other couplers and attachment points?
Everything but the tail cone, because the tail cone we could only get in 1 inch, but it said that it's, as far as
Well,
it goes,
not a separable joint.
yeah, just that's permanent.
Yeah, yeah. If it's a permanent fixture, we only care about the caliber lengths if it can separate
All right.
at that point.
Then yeah, we're at 6 inches.
Yeah. So if it's epoxied in place, then it doesn't have to be 6 inches. We'd prefer it to be, but yeah, we don't need the tail cone to be a 6 inch.
Yeah, and we have 6
Okay.
inches of avionics bay on either side.
Okay, good. Let's see, sugar pins. Let's see, the main chute is in the lower compartment, correct?
Yes.
So it splits in half.
Yep, splits at the nose cone and splits in the lower half of the avionics bay.
So it puts the nose cone off first for
Yep.
the drogue chute.
Yep.
And then it splits in half for the main.
Yep.
Okay. Yeah, that'll definitely avoid the main chute deploying at apogee. It's not recommended. When I was a student competitor, our rocket deployed its main at apogee. Our team is one of the reasons why teams aren't allowed to use Jolly Light chute releases. Because that's why ours came out. So it deployed at main.
Yeah.
Okay. Is there anything in the nose cone?
There is a bulkhead shoved as far as we could. So there's a volume up there, just in case swoop doesn't fit perfectly. But as of right now, we have plenty of volume that we won't need the nose cone.
Yeah, that question is mainly like if they're, because some people put electronics or like payloads in the nose cone.
Yeah.
Okay, so that section done, done, done. All right, so couplers is also fiberglass. Circular sound, yep. Wall thickness, yeah, the couplers are COTS, so that should be fine. Let's see, that's good. Shear pins. What epoxy did you use?
Total.
West Systems 206.
It's in the box. Would you
Yeah,
pick it up
West
over there?
Systems.
It's in the box over there.
Is that-
No, other box behind you. It is just the big bottle.
Yeah, West Systems
Yeah, we used
206.
206.
Okay, that's good.
Oh, and there's-
Okay, so we looked at the payload, propulsion section. All right, useful info. So that's it for the review itself, like of the rocket. What's remaining is a couple of things that I'll do myself, but a couple of useful pieces of useful info they'd like us to share. And particularly because you have not been to a competition yet. All right, so as you've noticed from the updates and notifications, the launch site is effectively in the middle of nowhere. Food and water supplied by each individual team. Last year at the Las Cruces sites, there were food trucks, but those do cost money. And of course, they have limited supplies. So just keep that in mind. You will need to transport yourself, your team, and the rocket to the launch site. I don't think it's applicable to you since you're in the US, but don't ship anything to Spaceport Midland or hotels or Airbnbs. But I think let's see, what method are you using to get to the competition?
We are flying as a team, and Tammy, the advisor, is driving her RV down with the rocket.
Oh, okay, very good.
We'll have driver down. That and the motors.
Perfect. Okay. On ship. Let's see. We will be providing tents, I believe, and tables, just as we did last year.
Nice.
So you will need to bring chairs. We don't provide those. All right, so the rest of these, let's see, that's not applicable to you since you're in the U.S. So just as with New Mexico, Texas can get quite hot. So expect temperatures well in excess of 90 to 100 degrees, well in excess of 90 degrees. We'll see if it gets above 100. So that means lots of water. Me personally, I try and drink small amounts of water frequently rather than like downing a whole bottle in like 30 seconds. Also sunscreen. I usually will apply sunscreen every 2 hours. But it's really up to you. Just bring sunscreen and wear it. We prefer not to deal with sunburn or heat stroke out at the launch site. And wear appropriate clothes, of course, as well. So hats are always good, sunglasses, light colored clothing, and closed-toed shoes. I usually wear hiking boots. That's both to prevent like sun and also from animals. Let's see. So you're flying to the launch site. What are your hotel plans?
We've got hotels booked. We've got travel booked, and we've got, I think, rental cars also booked.
Fantastic. Are you flying into El Paso?
I think Midland, yeah.
Ah, you're flying to Midland. Okay. Some teams are flying to El Paso. Good. All right, so another warning, don't paint rockets in the hotel, but since you're already painting it, that's not a problem.
There's a rule,
all team members that go past the flight line will need to be EEE members. They don't need to be certified. They just need to have EEE membership to go past the flight line. Does any part of your rocket require a ham license?
No.
Okay, so you won't need to worry about that. You definitely have a flyer of record. They're on the call. That's good. Okay. Let's see. You're not currently like ready to attend the competition, from what I can see, but you are quite close.
Yep.
And considering there still is about a month left, I would definitely say you're well on your way. Plus, you're geared to do a flight test next week. That would definitely mean you're ready by June. The rocket is definitely present mostly. Key team members did attend. Is Tammy your mentor as well?
Yes.
Okay. Yep. All right. Flyer record and myself is here. All right. So do you have any other questions that you want me to ask? Or do you want to ask me? Really quick.
No, I think we're pretty well set.
Yeah.
Perfect. Yeah, I'm not seeing any issues with your rocket, so you should be set for both your flight tests as well as being at the competition. Let's see. Definitely. Yeah, keep the recommendations. You're recording this, so you should be able to like rewatch this, as well as you'll need to send this to the recording. I think it's to general@ezra.org or something. There's an email address that you'll need to email this to.
Does it need to just be the whole video? Is it?
Yeah, so send the whole video as an MP4.
Okay.
Is what they're asking.
Pretty easy to do as an hour meeting, or do we gotta?
Yeah, my recording is at just under an hour.
Yeah, we'll be fine. We'll figure it out.
Yeah, so if you email it, it'll send as a Google Drive like link.
Okay.
Because it'll be bigger than Gmail. If you send it by Gmail, it's larger than Gmail's maximum file size.
Yeah.
But it should be pretty easy.
All right.
They just need access to it.
And then that's just as soon as possible after this?
Yes. Mm-hmm.
Okay.
Or at minimum before May 16th, which shouldn't be a problem.
Yeah. Sounds good.
Perfect. All right. Looking forward to seeing you in Texas. I almost said New Mexico.
Almost
And
close to New Mexico, so yeah.
I know it's 2 hours from the New Mexico border. So anyway, yeah,
All right.
good job.
Thank
and
you.
Thank you, Eric.
You're very welcome. Enjoy the rest of your day.
You as well.
Thanks, you too.
Thank you.